2006 BC, question number 3. An object moving along the curve, and the xy plane is at position x of t, y of t at time t. And we have dx of t, dx dt, and dy dt for time greater than or equal to 0. And we're given the point at time t equals 2, the object is at 6, negative 3. We want to find the acceleration vector and the speed vector of the object at time t equals 2. So in order to do this, this is again is a calculator question, so we're going to bring in the calculator and we'll put in our dx dt and our dy dt. So y1 will be dx dt, that's the inverse sine, so it's second sine of 1 minus 2 times e to the negative x, or negative t in this case. And so I have arc sine of 1 minus 2e to the negative x. That's my dx dt. My dy dt is 4x divided by, and I'll need parentheses there, 1 plus x to the third power over, and we have our two functions in there now, 4x over quantity 1 plus x cubed. So in order to find the acceleration vector at this point, I'm just going to go ahead while I'm here. In order to find speed, what I need to do is find the square root. It is the square root of dx dt quantity squared plus dy dt quantity squared. So I'm going to second square root vars y vars function y1, that's dx dt squared, plus vars y vars function y2 quantity squared, and so that is my speed function there. So I'm going to go in and turn that off for the time being. What I need to do to find the acceleration is to find just the value. Well, I'm looking for the slope of each of those y1 and y2 curves. So I'm going to go out, zoom, standard. That's my one curve and my other curve, and I'm trying to find this at t is equal to 2. So I'm going to second calc, find the derivative of, you can see there that I'm on dx dt, that's the sine inverse for x equals 2, and it gives me 0.396. Now I need to find the same thing for the other curve, for the dy dt curve. So I have second calc, and I need to do this first. I need to say that I want a derivative, but notice that it puts me on the dx dt curve. I'm going to select up. Now I'm on the dy dt curve, and I tell it at time t equals 2, I'm looking for that value, and it's negative 0.741. And so I have the acceleration vector at time t equals 2. In order to find the speed at that point, what I'm going to need to do is go in, turn off the other two functions, turn on the speed function, and I'm going to zoom standard once again, and it gives me that curve. And all I need to do now is find the value of this function, because it is the speed function. The value at time t equals 2 is 1.208, rounded to 2 decimal places. So note, when I was looking for the acceleration vector, I had to find the derivative of the dx dt and dy dt curves. But when I was looking for the speed, I just needed the value of dx dt squared plus the value of dy dt squared, and then the square root of that sum. And that gives me the two values that I need for part A, and I'll continue with part B in the next video.